Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the Laplace transform of series RC circuit. Okay, so in this series RC circuit, so we have to find out the total current response and voltage drop across the resistor and voltage drop across the capacitor. Okay. So here I am taking the one series RC circuit. Okay. So here I am taking the one series RC circuit. In this RC circuit is connected across the one voltage source. So plus minus voltage is V of t, resistor is R, capacitor is C. So it is a series circuit. In series circuit, what is the constant term? Current is the constant. So here I am taking current as I of t. But we are having the different voltage drops at resistor and at capacitor. At resistor R, voltage drop is VR. At capacitor C, voltage drop is VC. Okay. So now at resistor R, VR equal to I of t into R, this is according to Ohm's law, V of t into R, and at capacitor C, the voltage equation Vc equal to 1 by C integral of I of t into dt. Okay, so VR value and Vc value. So voltage drop at resistor VR equal to I of t into R, voltage drop across the capacitor Vc equal to 1 by C integral of I of t dt, right? So now in this series circuit we need to apply the KVL. It is a one single loop. In this single loop we have to apply the KVL. So now apply KVL here. So we'll get plus V of t minus VR minus Vc equal to 0, or V of t equal to VR plus Vc. Now substitute this VR value and Vc value in this equation. So we'll get V of t equal to VR I of t into R plus Vc 1 by C integral of I of t into dt. Okay, so V of t into I of t into R plus 1 by C integral of I of t. Now for this equation we need to apply the Laplace transform on both sides. So here apply Laplace transform on both sides. Now so Laplace transform of V of t equal to Laplace transform of I of t into R plus Laplace transform of 1 by C integral of I of t into dt. Now we have to simplify this equation. So Laplace transform of V of t is V of s by s equal to, so Laplace transform of I of t into R is constant. So R into Laplace transform of I of t is I of s plus, so Laplace transform of 1 by C integral I of t dt. In that 1 by C is constant. Now Laplace transform of integral I of t dt is I of s divided by s is the equation, right? Now take I of s as a common here. So V of s by s equal to I of s into R plus 1 divided by Cs. Now by using this equation we have to calculate the current response. We need to calculate the current response in S domain first. Okay. So here I of s is there. So I of s is equal to, so cross multiplication here V by S into 1 divided by R plus 1 by CS. Now simplify the equation, that is equal to V of S by S into 1 by, here LCM is CS. So here RCS plus 1. So S get cancelled. So C into V of S into 1 divided by RCS plus 1. Now this equation we have to write in terms of S1 divided by S plus A or 1 divided by S plus B, like that we have to write. So for that, C into V of S into 1 divided by, so in this equation I am taking common, I am taking RC as a common term here. So RC into S plus 1 by RC, right? So here C get cancelled. So V of S divided by R into 1 divided by S plus 1 by RC. This expression is the current expression in S domain. Now this equation we have to convert into the time domain. For that we have to apply the inverse Laplace transformation. So here apply inverse Laplace transform. So Laplace inverse of I of S equal to Laplace inverse of V of S divided by R into 1 divided by S plus 1 by RC. Now Laplace inverse of I of S is I of t, that equal to Laplace inverse of V of S by R is V of t divided by R into e to the power of minus 1 by RC into t. This is the current expression of the series RC circuit. So I of t equal to V of t by R e to the power of minus 1 by RC into t, right? This is the total current response of series RC circuit. Now calculate the voltage drop across the resistor, that is VR is equal to I of t into R, that is equal to, will get R get cancelled. So we'll get V of t into e power minus 1 by RC into t, VR value. And for the inductor value, VL equal to L into di of t divided by dt, that equal to L into d by dt of I of t. What is I of t here? V of t divided by R into e power minus 1 divided by RC into t. So here VL equal to di of t, so di of t divided by dt. So we are having the voltage equation, VL is equal to L into di of t divided by dt, right? For the capacitor, VC equal to 1 by C integral of I of t into dt, that is equal to 1 by C integral of I of t. What is I of t? V of t divided by R into e power minus 1 divided by RC into t, that equal to, so 1 by C into, in this equation V of t by R is constant. So V of t by R into e to the power of minus 1 by RC divided by minus 1 divided by RC. So RC get cancelled. Then VC equal to V of t. So minus V of t into e to the power of minus 1 divided by RC into t. This is the voltage drop across the capacitor. This is the voltage drop across the resistor. Okay, here is the Laplace transform of series RC circuit. Okay, so thank you one and all.